Focus is going to be working on adding fractions with unlike denominators by finding equivalent fractions by creating the least common denominator. So we worked on the skill of creating common denominators in the previous lesson. So today we're just going to take it one step further by taking those equivalent fractions that we created and adding them together. So when we are adding fractions with unlike denominators, the first thing that we need to do is we need to go ahead and create the equivalent fractions. So we need to get them to where they have the same denominator. So if I need to do the step of where I list out multiples, I'm going to list out multiples. And so what I'm going to do is I'm actually going to rewrite this problem, and I'm going to rewrite it vertically. And the reason that I'm going to write this problem vertically is now I have workspace to find the equivalent fractions. And so I can do my work all over here, and then I can very cleanly show the modeling of my math. So the first thing I need to do is, if I don't know what the least common denominator is for 4 and 8, is to list out my factors. So I'm going to start listing out my factors of 4. So I have 4, 8, 16, 20, oh, I forgot 12. 12, 16, 20, 24, and I'm going to stop there. Now, I'm at the point where I can recognize that 8 is going to be my least common denominator, because right here I saw 8. So that means that 3/8 is actually not going to change. It's going to stay at 3/8. Okay, the next step that I'm going to do is I have to look at, if 8 is my common denominator, I need to look at what I multiply 4 by to get to 8. So 4 times what value equals 8? Well, if I listed out my multiples, I can count. So it's just 1, 2. So it's 4 times 2. And again, whatever I do to the denominator, I have to do to the numerator. So I'm going to multiply 1 times 2. Okay, so now I have my new equivalent fraction. So I have 1/4 is equal to 2/8, and then 3/8 didn't have to change at all because 8 was the common denominator. And so I simply, at this point in time, am going to add my numerators together. And when I add my numerators together, I end up with 5/8. So the next problem that we are going to take a look at is going to be your visual learning on page 384. And it says, Alex rode his scooter from his house to the park. Later, he rode from the park to the baseball practice. How far did Alex ride? So he started off by riding a half of a mile, and then he rode a third of a mile. And again, habit is just to do that. I'm going to change it, and I'm going to write it vertically, because now I have room. And the reason that I do this is now I have room to find my equivalent fraction. So I'm just going to go ahead and set up my workspace all the way through. And so what I need to do first is I need to go ahead and list out those multiples to find what's in common. So I have 2, 4, 6, 8, 10. So put in my commas, and then I have 3, 6, 9, 12. And so I'm going to stop right there, and I'm looking, I'm going to see, do I have anything in common? And the value that I have in common is going to be the 6. So 6 is going to be my least common multiple. With 6 being my least common multiple, I'm going to go ahead and write that in my equivalent fraction space that I've created. And I have to look at how many times do I multiply 2, or what value do I multiply 2 by to get to 6? And the answer is 3. And again, the rule is whatever I do to the denominator, I have to do to the numerator. So I write 3 up on the top, and I'm going to multiply that by 3. And then to get here, what I would need to do is 2 times what equals 6? Well, or sorry, 3 times what equals 6? It's going to be 3. So, it's not going to be 3, it's going to be 2. I'm just boogering up this problem. It's 3 times 2 equals 6. So 3 times 2 is 6, which means I do 1 times 2, and I get 2, 6. Then I add the numerators together, and so I get an answer of 5, 6. All right, so let's move on to the next problem. It says, in the example above, so I'm down on the convince me, in the example above, would you get the same sum if I used 12 as the common denominator? So we'll just remember that I got 5, 6 as my answer. And so now what I'm looking at is I had 1/2 and I have 1/3. And let me make this where I have 1/2 and I'm adding that to 1/3. And my common denominator is going to be 12. And so with my common denominator 12, I need to see if I'm going to get 5/6 as the same sum. So I have to look at 2 times what equals 12. So 2 times 6 equals 12, which means I'm going to do 1 times 6 because whatever I do to the denominator, I do to the numerator. And so 1 times 6 is going to be 6. And then here I have to look at 3 times what equals 12. That's 3 times 4 equals 12. So I'm going to multiply 1 by 4, and I'm going to get 4 twelfths. So I'm going to add these together, and when I add those together, I get 10 twelfths. So the question that we now have is 5/6 going to be equal to 10 twelfths? And so what we need to look at is we need to look at whether or not the fractions that we have are in what's called simplest form. So simplest form is where I cannot divide the numerator or the denominator by the same factor. So I'm getting it to where it is the smallest possible value. So these are still an equivalent fraction, but smallest possible value. So if I take a look at 5 and 6, their only common factor that they have is 1. 1 is the only common factor. So this is already in simplest form. But if I take a look at 10 and 12, 10 and 12 have a common factor. They both can be divided by 2. So when I'm looking for simplest form, I'm looking to see, can I divide both the numerator and the denominator by the same value? In this case, I can. I can divide them by 2 because they're both even numbers. So when I do 10 divided by 2, I get 5. And when I do 12 divided by 2, I get 6. So the values are the same. These two fractions are equivalent fractions, even though they have different denominators. It's still the same amount of distance that Alex would have traveled on his bike. Okay, so you need to just do a quick check to make sure that your final answer, your sum, is always going to be in that simplest form. And this will be a skill that we continue to work on and practicing, is reducing and finding those fractions in simplest form. All right, so if we move into your next example. So the next example that I have is I have 5/12 and I'm adding that to 1/4. And again, I do this so I have my workspace. And so first thing I'm going to do is I'm going to go ahead and I'm going to list out my multiples. And so my multiples of 4, I always like to start with the smallest value because sometimes the larger number can be a value of the smallest number. And by listing out my smallest value first, I can see that. So I have 4, 8, 12, 16. And notice right there, I have 12. So the least common denominator is going to be 5/12. So 5/12 is going to stay 5/12. I don't need to multiply it by anything. But 1/4, I'm going to multiply by a value to get to 12. And so 4 times 3 is going to be equal to 12, which means I'm going to multiply 1 times 3. And so when I do 5/12 added to 3/12, I get 8/12. And so now I need to ask myself, is this fraction in simplest form? So can I divide this fraction out and to make it a equivalent fraction with a smaller value in the numerator and the denominator? And my answer on this one is yes. They have a common factor of 2. And so when I divide them out, I end up with 4/6. And then I look at that and I say, okay, did I find my fraction in simplest form? And the answer is no, because I can still divide this factor out. I can divide this again by 2. And when I divide it out by 2, I end up with 2/3. So now I'm going to take a look at 2/3 and see, does 2 and 3, do they have a common factor I can divide by, or a common divisor? And the answer is no. Their common divisor is 1, and I don't need to show my division work by 1 because anything divided by 1 is that value. So my answer for this problem of 5/12 added to 1/4 is going to be 2/3 because it is in simplest form. We always put our sums in simplest form. If we take a look at problem number 1, it says an example at the top of page 384, if the park was 1/8 of a mile instead of a third of a mile, how far would Alex ride his scooter and all? So we're doing now 1/8 added to 1/2. And so I'm going to go ahead and set that problem up, list out my multiples of 2. So I have 2, 4, 6, 8. I'm going to stop right there because I have 8 is a common multiple. So 1/8 is going to stay 1/8. And then 1/2 I'm going to multiply by a value to get to 8. And so 2 times 4 is equal to 8. And so 1 times 4 is going to be equal to 4. Add my numerators. You do not have to circle them. I circle them just as a reminder that that's what I'm adding. So 1 added to 4 is going to be equal to 5. And then 5/8 is going to be my answer. And then I need to look to see if I can put that in simplest form. And so 5 is an odd number, 8 is an even number. 8 is not a multiple of 5. So this is in simplest form. And I need to make sure, because it was an answer that had a label, had a unit of measurements of miles, I'm going to make sure my answer has a unit of measurement. So it's 5/8 of a mile. All right, so if we take a look at number 2, it says Rico and Nita solved the same problem. Rico got 6/8 for an answer, and Nita got 3/4 for an answer. Who is correct? And then use the term equivalent fraction in your explanation. So the first thing we need to look at is we need to look at whether or not both fractions are going to be in simplest form. So 3/4 is in simplest form. I can't divide this out by any other value. I can't divide 3 by 2. I can't divide 4 by 2. I have to, again, whatever I do to the top, I have to do to the bottom. And so I cannot divide by different values to create equivalent fractions. And so I'm going to see if 6/8, do they have a common factor I can divide by? They do. I can divide by 2. And so when I do 6/8 divided by 2, I actually end up with 3/4 as my answer. So both are correct because I'm using that math, the language of the discipline, because 6/8 and 3/4 are equivalent fractions. So the next problem that we're going to look at is number 3, to where I have 1/2 added to 1/4. And so I'm going to go ahead and list out my multiples of 2. So I have 2, 4, 6. I'm going to go ahead and stop because 4 is a value of this denominator. So I'm done. So 1/4 can stay at 1/4. And then 1/2 I'm going to multiply by a value to get to 4. And let me make that a little smaller so they're lined up. So to equal 4. And so 2 times 2 is going to be equal to 4, which means I'm going to multiply 1 times 2 to get 2. I have 2/4 added to 1/4, and so I get 3/4 as my answer. For your independent practice, what I'm going to have you guys do is you actually have an adding fractions sheet that you are going to work on. So you are not going to be doing 7-3 within your book. You're going to be doing an independent practice using the adding fraction page that I have for you.